my pleasure to call upon stage our first keynote speaker. He became very passionate about cryptocurrencies very early on. So he'll be talking about decentralizing web services today, and we have with us the co-founder of the Unigrid Foundation, Mr. Evan Green, everyone.
So my name is Evan. I'm co-founder of the Unigrid Foundation. I'll give you a quick rundown of what it is that we're building and what Unigrid is before I start. So Unigrid is a layer 1 blockchain solution where we will be providing cloud-based internet services. So today we want to talk about blockchain scaling and the next generation in the internet and cloud. Perfect. So the current internet has a problem. The way we see it, it's not, say, sustainable or at the level where we think it should be. It's very prone to DDoS attacks, or denial of service. Some of you may understand that term better. What that means is that hackers will hijack other computers on the internet and basically use their resources to send in packets of information to a centralized server. What that does is it can cause breakdown of traffic because the traffic that's going to that one server will cut down the service to where it basically becomes unresponsive. The other problem with that is that because there's so much traffic going through the backbone of the internet, that other networks can have a problem because the way the current internet works is that you have, a backbone of connection between centralized server points, and to get to, that specific server that's being attacked, it's going to have to route through a certain town or city, so sometimes you will experience a DDoS attack, even though it's not your specific server or your country that is being attacked. And then we also see a lot of information that we think should be free to all. We think it should be an inalienable right for people to have access to information. You can't come to the truth without seeing all sources of information. And so we believe that that's something that everyone should have access to, and it's not something that anyone should be blocked from seeing or just not having access to it. And services on the internet are very easily interruptible as well. So say, a traditional service on the internet is running from typically one centralized server with, say something could happen to that server itself where it goes down, you lose access to that service. Or it could be a problem with, maybe there's an application error. That service goes down. So we think that that is a problem, and we think that that is also something that is fixable, and we can provide the help. So how can we help? Unigrid, we can help by mitigating the DDoS attacks without having one single point of failure. So the way Unigrid works is that the network doesn't have one single point of where data is served from. So the serving of data can come from many different locations. So say we're here in Dubai and we want to access some data or some information or a service. What the network will do is it'll realize that. It'll say, okay, I know where you're trying to access the data from, and it'll go to the closest location. Say it's around you, maybe it's in United Arab Emirates, or it's in, could be in Israel or Egypt, somewhere, just in the region. So it'll pull data from that location. What happens then is that for a DDoS attack to function, it needs one point to attack. With the Unigrid network, because the data doesn't have that single point, it's pretty much impossible to attack it. You would need an extreme amount of resources to be able to attack all those different areas. And we also want to provide unblockable services. So what that means is that, especially in, current world situation right now, we're seeing a lot of services get cut off because of maybe it's point of view or it's somebody just doesn't like them, and those services get cut off and nobody has access to them. So with Unigrid, that becomes something of the past, to where those services can always be available no matter where you are. And we also say that services can always be available. We're always online. What that means is that because you have the way our network functions is that it is running in many different locations. So instead of it running from one centralized server, they can go offline, it can have issues, it can have a problem, go offline. This service will run in many, many, many locations. So this would run globally to where, if I put up a service and say I upload it here from Dubai, it'll spread across the network, which is just a web of nodes, and it can be accessible in Hong Kong, it'll be accessible in Los Angeles, in London, wherever you are. That service goes around the web or around the network. And then permanent data storage. So this is a big problem, especially with companies that handle big data. They don't, they have a problem where sometimes they're running from one centralized server location, and they need to back up that data. Backing up that data takes quite a bit of time because you have to move it from one location to another, and typically what people will do, or companies will do, is they'll move it from one data center and they'll move it to another data center. Which is really tedious, and it gets very expensive very quickly. So what we provide is once you pay it forward, and you pay forward for that data to exist on the network, it'll be accessible forever, and it's essentially living on the blockchain. As long as the payment is made for it to exist for that amount of time, it's going to stay there forever. And some statistics. So over 50% of cloud services were owned by 3 corporations. So what happens there is you have a lot of centralized power controlling price, controlling what types of services run. It's not a very democratic network. And that's just in cloud services. So it's even higher for the amount of web traffic. The web traffic that runs through the backbone of the internet, it's even higher. I think it's closer to 80%. So we see that as a problem, to where we want things to be more democratic, to where people have a say in how the internet that they use functions, and how it affects everyone's lives. So everybody should have a say in how it works. And as far as the cloud computing market, and this is just cloud computing, the market is projected to reach about $482 billion this year. So that gives us, as a startup, quite a lot of room to move into and expand. And that even a very small percentage for us allows us to grow quite quickly. Sorry about that. I think I'm double miking it. And probably about a third, probably even more than a third of businesses experience regular DDoS. And so what that means is, there's companies and countries that experience a constant threat and they're constantly having to deal with this. So it's, it might not be a problem to, say, an end user that's just trying to access information. Maybe they're like, oh, it's downline, it's offline, it's, maybe they'll come back tomorrow. But for a company, they spend a lot of money on preventing these attacks. They use other different services and have to check and see where you're coming from, prevent and mitigate these attacks. So we think that that's something that, it should be, it's fixable, and so that's something we want to help contribute to. As far as helping, yes, we think that we can help the people. So what does that mean? Well, for one, there's censorship. Censorship is a problem no matter where you are. There's always some sort of censorship, and there's lockdowns of what you have access to and what you don't have access to. So, we believe that everybody should have access to that information. We think that's a freedom everyone should have. Stopping repressive regimes. So we see a lot of that around the world, where the voice becomes one channel instead of it being, you know, 4 or 5 opinions or 6. It's just one voice, and that's all the people have access to. And we want to help change that. And then as far as the data, we want end users to have the control or have, you know, the data is their ownership, right? So what that means is that, say, for example, you have some medical records and you want to store medical records on the network, but you only want to give certain people access. So this network would allow you to store data like that that's very sensitive and personal, and only allow the person that you give access to access that data. So what we'd like to do, we'd like to make the network, or we will be democratic, so anybody can join. What that means is that initially in the beginning we'll see a lot of servers that will come online with a small amount of Unigrid. They essentially can start up a node with a very small amount of tokens, and those get locked. And what happens is their resources on that server become part of the network. The network has access to it. So it's a shared resource network. In the future, we see that going from just being servers, you know, where it's fast servers running in the data center, to where they're also running on your cell phone, running on a toaster, running on a refrigerator. That will probably happen. And then voting rights. We think that, you know, this needs to be a democratic network. So the only way that we believe that an internet of the future can function is that if it's democratic. People need to have a say in what happens on it and how it functions. So what we mean by that is that, say, we as the developers working as part of the foundation, we support the network. Our oath is to help the network, and that is all we're concerned with. But if we create something and say we have a proposal for a change protocol, and the network, each node runner gets a vote. Got to pause here. Sorry about that. Essentially, people would have a vote. So they would have a vote for if say we make a change, they don't want it, it basically comes off. It doesn't go on the network. So everybody can have a say in that. So we're talking about down servers and services going offline. Things happen, sorry about that. So we're talking about voting rights and how end users can have a vote on the network. We also want to make it autonomous and scalable. So the network should be able to function on its own. It shouldn't need somebody else to interfere for it to be decentralized. It also needs to be scalable. So part of our solution is implementing data striping and sharding to where the network itself scales indefinitely. So as the network grows, it becomes more and more it has more resources, becomes, you know, something that can just scale indefinitely. So we will include compute work, storage capability, and anonymous internet access. So the compute work would be something, say, I'm a research center and I need a very large amounts of compute cycles. We can provide that. Somebody can rent that space on the network. And of course the storage capability to where all of the resources on the network become available to the end user. And then also making giving anonymous internet access. So this is something that we will implement very early on, where the network will have a VPS service built into it, to where people connect to the internet and browse regular internet through our network anonymously. And then we're also going to make this transactionless. So our blockchain technology doesn't use transactions. If you imagine that, it's a blockchain, but we don't use transactions. So what is a grid node? A grid node is essentially a server that will supply resources to the network. So an end user can take a certain amount of tokens, and if they want, they can set up a grid node and provide those resources to the network. So this, obviously it supplies the CPU cycles that are on that server, the RAM, the data storage, and then eventually later on we'll also add GPU cycles. So that will be available in the network as well. And this will replace traditional servers. So a lot of what you have in data centers now is people rent out space on individual servers to where you could have one machine that may have 16, 20, sometimes more of different pages or different services running on one machine. So that can have problems. So if you have something, say DDoS attacking somebody else's service, then yours is affected as well. So in turn, that grid-node runner, he receives a reward for that contribution of resources. And that is score-based. So what that means is that if somebody has a higher computational power, then they'll be rewarded higher, and they'll get more work. If somebody has more hard drive space, they'll get more work. So it becomes an open competition on the network. And that encourages people as well to use better resources, to apply them onto the network. So it helps keep things decentralized, but also encourages it to grow. And that will, in the end, give us better performances. So Web3 and Internet 2.0. We hear a lot of buzz and talk about Web3 right now and how it's helping decentralize the finance world. So what is Internet 2.0? This is what we like to call our blockchain solution because we're very low level. Web3 is very high level. So Internet 2.0, we like to say that we're going to have the data redundancy, so where the data is automatically sharded and spread across the network. We install data privacy standards, that is just a default, and then services that are always online. So we see in the future that the Web3 world, where it's running on centralized servers, but wanting to be decentralized, we want to have some of those services start running on a network like ours, where it can be fully decentralized. So some of our goals, obviously we want to mitigate those DDoS attacks. We want to provide freedom of information. We think that everybody has a right to that. And we want to keep services running nonstop. So we don't see the reasoning behind how the current internet functions, that you should lose access to services. In this day and time, that's something that shouldn't exist. And we want to build a democratic internet to where everybody can partake in it, and then also everybody can have a say in how things move forward. And then, of course, data privacy, to where you're the ownership of your data. It's not controlled or run by somebody else. So sorry about that slight intermission there, but thank you everybody for listening. And we're at booth 10 out here if anybody is curious to learn more. But thank you very much.